So we're going to do a little bit extra today to finish off the things that we had with the harmonic identity. And we're going to be thinking about exploring maxima and minima. Remember, maxima and minima just means the plural of maximum and minimum. And it says in this table that we've got here, what is the maximum value of the expression? We could have investigated the minimum. I just want to investigate the maximum. What is the maximum value of this expression? And determine the smallest positive value of theta in degrees at which it occurs. Now, we're not having to do the harmonic identity to any of these things here. I am already having done that bit for you, okay? We're just going to be thinking about how do we make these overall expressions be as big, as small as possible. And so there's a few things that we need to remind ourselves of. When you think of sine theta can take any value between
0 and 1.
No,
Minus 1.
-1 and 1. So the maximum value of sine theta is 1. And it's the same thing for cos theta, that cos theta can be in between 1 and -1. So I've written a little hint for us to try and do some of these things here. Investigate how the expression, these are the expressions that I have here, investigate how the expression behaves when you set sine x or cos x to be one of its extreme values, to set it to being either 1 or -1. So this first one is going to be pretty obvious, okay? The maximum thing that sine theta can be is 1, so the maximum thing that the overall thing can be is just 20. That's the maximum thing that that can be. This maximum occurs when sine theta is 1. So it occurs when sine theta, bless you, is 1, and we want to know what is the smallest positive value of theta in degrees. So you can either say to yourself, what is the inverse sine of 1? Or you can think to yourself, when is sine at its maximum? Or you can do it on the calculator. 90. So theta is 90 degrees in this example that we've got here. But it's not just 90 degrees. There are other answers it could be. Can you just give me one of the other answers it could be?
270.
Not 270. 270 would be a -1. 450. You could add 360, or you could take away 360 to get -270. The reason I haven't said 450 or -270 is because I wanted the smallest positive value. Okay? So I want you to think to yourself down here, you want these expressions to be as big as possible. And so you need to decide, are you going to make the sine theta 1 or -1 to make it be as big as possible, and then try and find out that value that theta will be to make that maximum. So I'm going to give you a couple of minutes to have a go at these few, and then we'll go through them together. I don't mind you talking to the person next to you about this to try and think about what might be the overall biggest or smallest thing. Just try subbing in either 1 or -1 for those values. Yeah.
Does 0 count as positive?
Where are you getting 0 from?
Second one.
No. Because you can make it... that if theta was 0 in the second one, it would just be 5 minus 0. So you're saying 5 is the biggest thing it can be. I disagree with you.
5 degrees 10 is then.
Well, start doing what I advised you to do, Zahiral. Rather than doing your own thing, start taking my advice on board. If you feel like it, if you fancy it.
I know, but I'm thinking, I don't know. Basically, yeah, as an explanation. When someone that's something that's
That's what I'm saying. It's not hard. Yeah, but your minus
Sine.
that's still fine. So you want it to be minus 10 is minus 1 plus 1 is minus plus 13 by 2.
Okay, 30 seconds more to have a think about these.
I was supposed to read minus 10. Hold on. Listen. I'm losing. Does it not?
Oh, in degrees.
This one, yeah.
No, it's not that. Yeah, no, I saw it.
Yes, the same. As you can manage with
I get it, but that's fine. What do you even write here?
Okay, so I want to hear some of your thoughts. If we haven't finished it, this is still part of us being able to do some of this together as well. So Zahira, have you changed your mind about what you think the maximum could be of this expression?
Yeah.
What do you, originally you thought it was 5 when this thing was 0, but what have you now since changed it to? 15, okay. When is it equal to 15?
When sine theta is minus 1.
Good. When sine theta is minus 1, so it's not always going to be what you expect here. This time, the overall expression was a maximum when sine theta was a minimum because of the fact that it was negative in front of it. So if we made sine theta minus 1, you'd have 5 minus 10 multiplied by minus 1, which is 5 plus 10, which is 15. So when sine theta is minus 1, what is the value of theta? 270. Good. You can either see it from the graph or you can do the inverse sine of minus 1 to find out that this expression would reach its maximum when theta is 270. What's the overall maximum of this one that we've got here? Anyone? 3. It's just 3, right? Because cos can go between 1 and minus 1. And so we're going to make this overall thing be as big as possible. So what we're actually going to do is we're going to make cos of theta plus 20 be equal to 1. Now, when you think of the cos graph, when is cos equal to 1? For what values of?
0.
At 0 or at 360. So either theta plus 20 is 0, which gives you that theta is minus 20, or theta plus 20 is 360, so theta is 340. Just think about why that's true. If theta was minus 20, you would have done minus 20 plus 20, you get cos of 0, which is equal to 1. Or if theta was 340, you'd have 340 plus 20, which is 360, and cos of 360 is also equal to 1. But we need to pick one of those answers. Which answer do we pick and why?
340.
340, because smallest positive value. This one is not positive, so we will not be using this one here. So you do need to make sure that you also always think of the value that you actually need for that particular one. This is probably the hardest one that we've got here.
That's not the smallest positive value.
This one, I think so.
What, 20?
If it was 20, it would be the cos of 20 plus 20. Yeah? It's because that one went into negative. This one's a lot harder though, right? Just ignore this fraction here for a second. When I have fractions, let's say I had 2 over 10 or 2 over 100. Which of these ones is smaller? The second one. So if you want to make a fraction smaller, you have to have the denominator being bigger. If you want to make a fraction bigger, you need to make the denominator smaller. Okay, let's just write that down. For a maximum, we want the smallest denominator possible. For a maximum, we want the smallest denominator. That makes sense, right? So here, what's the smallest thing that this denominator can be? 7. Because the smallest thing that sine can be is minus 1. So you would have 10 plus 3 times minus 1, which is 10 minus 3, which is 7. So the maximum is 2/7, and this occurs when sine of theta minus 30 is minus 1. So just to remind us, we're trying to make this as big as possible. We make this as big as possible by making the denominator as small as possible. We make the denominator as small as possible by making this as small as possible, which is making sine of theta minus 30 be equal to minus 1. So when I solve this, theta minus 30, sine is minus 1 at 270. So theta is 300. That's the smallest value that we have there of 300. And you're probably thinking, who cares? Because what we do later in this chapter is we model real life situations, which includes things like the way that the sea changes and the tide moves and temperatures and things. We can make predictions about stuff according to these angles, where these angles are going to represent time or other variables that we have. So that's why we want to try and make predictions about how these things will behave, okay? So there's no kind of surefire way, apart from just looking at the expression and thinking to yourself, how do I achieve the thing that I want it to be? Usually, you will make sine or cos its maximum or its minimum. But we are going to have a look at an example where we do neither of those things. And maybe you can think to yourself now, okay, well, if I'm not picking one of the extreme values, I wonder what I might pick and why. But we'll look at that in just a moment. So there are a couple of questions linked to this in exercise 7E. Question 14 is the one that you're going to do for homework. So I'm going to do one question now that's similar, and then you're going to just do it as homework, okay? Because I would rather you have a bit of time away from it, and then you can always review this to look at it. So this is an exam question where I think you could easily do the first part of this question. In fact, I'm sure we've done this first part of the question before, and we're then actually going to mostly be concentrating on part B that we've got. So it says here, express 6 cos theta plus 8 sine theta in the form r cos theta minus alpha, blah, 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 blah. Give the value of alpha to 3 decimal places. Well, you've done tons of homework on this, so this should happen pretty quickly. We're going to go quite speedy here. So r cos theta minus alpha would be r cos theta cos alpha plus r sine theta sine alpha. And we think that we're trying to make 6 cos theta plus 8 sine theta. So can anybody tell me what r cos alpha is the same as? And r sine alpha?
8.
Okay. So what would r be equal to?
10.
10, because it's the square root of 6 squared plus 8 squared, which is 10. How did Haroon know that so quickly? So 3, 4, 5 Pythagorean triple, isn't it? 3, 4, 5. 3, 4, 5. You're probably thinking, why am I saying that? Because obviously they're all doubled, okay? And then our value of tan alpha is 8 over 6, which is 4 over 3. And so alpha is the inverse tan of 4 over 3. And you better be in radians mode here. Am I? Yes, I am. And they want that to 3 decimal places, which is 0.927 to 3 decimal places. So our answer to part A is that 6 cos theta plus 8 sine theta is 10 cos theta minus 0.927. And so if you've done that in part A, you know for sure you're going to need to use it in part B. So I'll just give you a chance to write that down. If you've written it down, you can start thinking about what we'll do in part B. Okay, so whenever they have a part A and a part B with these kind of trig things, you need to look out for what happened in part A to use it in part B. Now, our one is actually a complete replica. This thing that I've got written here appears exactly here like this. but you may see it written in similar forms, maybe not identical. You may see something where it says 12 cos theta plus 16 sine theta. So it's the same thing, but doubled. So you need to look out for that. You need to look out for things either being exactly the same or similar to it. You may also see something written in a different way. Maybe you might see something, instead of it being 6 cos theta plus 8 sine theta, it may say 6 cos 2x plus 8 sine 2x. In which case, you could use the first part of the question, but instead of using theta, like here, you would replace the theta with 2x. So I'm just trying to tell you here, this bit I've highlighted in yellow will always be related, but it may be slightly adapted. You just need to look out for that. In this first example, though, it's exactly the same. So I'm just going to ignore those two that I've written. Just trying to give you a heads up for what you might come across in exam-style situations. So what I think is going to be a sensible thing to do here is to take this function, which is p of theta, and to rewrite p of theta. So it's going to be 4 over 12 plus. Well, I'm not going to write this yellow bit anymore. I'm actually going to write the thing that it's equivalent to, which is 10 cos of theta minus 0.927. And the first thing that we want to do is to find the maximum value of this. When do you think this maximum value will occur? When cos is minus 1, okay? So the max value will occur when cos of theta minus 0.927 is minus 1. Because if we make the denominator as small as possible, the overall thing will be as big as possible. If you couldn't think of that in the panic of the exam, just try subbing in either minus 1 or 1 and see what you get. So the maximum value is 4 over 12 minus 10, which is 4 over 2, or 2. And it also wants you to find the value of theta at which this maximum occurs. So I'm going to take this piece of information and I'm going to find out what theta is. So I have cos of theta minus 0.927 is equal to minus 1. So I can say that theta minus 0.927 is equal to the inverse cos of minus 1. Now, you can either do the inverse cos of minus 1 on your calculators, or you could just think sensibly by knowing your graph. What is that, the answer of that going to be? Pi. Because if you think of the cos graph, it's at its minimum at minus 1 when it's pi. And so the value of theta at which this maximum occurs, we just need to add 0.927 to pi. And then just check it's in range, which it is going to be. And you get 4.069 to 3 decimal places. And I'm just going to put this on a graph for you on Desmos, so you can see what's actually happened here as well. Okay, so here is the graph of 4 over 12 plus 6 cos theta. I've done x instead, plus 8 sine x. And we wanted to find out a maximum point. A maximum point is here at 4.069, as we predicted. Okay? What do you think the gap is going to be between this maximum point and this maximum point? Oh, kind of should. 2 pi, exactly. If I change these to 2x, who thinks they can imagine what the gap will be between the maximums? Pi. Why, Sam? Good, it gets compressed by a factor of 2. So the gap is now got a gap of pi. You can see that that's a gap of pi between those ones. What about if I doubled these coefficients here? Well, let's see what happens. I think it's going to be a bit different. I think, let's just try. I think it's actually going to go into some kind of negative-y kind of bits. We get like a much stranger kind of graph because of the fact that the maximums that we had here, the denominator starts becoming negative, so it gets a bit funky. So ignore what I've just said there, okay? So you're going to have a go as homework, and I deliberately want to do this as homework rather than in class today. I want you to review this question. It's exercise 7E. It's question 14. That's going to be one of the things you're going to be doing homework. It follows a very similar pattern to this one that we've got here, okay?